Welcome back to Archean, episode 3 of season 1 playthrough. And in the previous episode, we constructed a initial starter mining vehicle. We did some initial coding, and now for this goal, this episode is to go ahead and finish up the coding and test it out and see how it works. So now here I am defining the seat channels. The channel 0, which is the using channel, that contains, it's 0 if you're not seated, and it's non-zero if you are seated. And when I say non-zero, that's the important part to test for, because the value can be 1 or some large number, which effectively is a token. The reason why I need the token, if you use the HUD controller, so the HUD controller is a chip that you pass the token to, and for that, then you can basically draw on the screen. So it's basically the same as the F1 HUD, except it only comes on when you, like an example, use a vehicle of some sort, or use something with a pilot seat, should we say. I don't use it. I use it in this vehicle that if you're not seated, I apply the brakes. That way, if I get out, it doesn't go rolling off somewhere. That's important if you're in a hilly area. I grab the channel 1, which is forward, backward, left, right, and I use 4 for the brake, just because I just happen to use it, and I keep using it so I don't have to relearn a new key for braking. Okay, so basically every game tick, I'm going to go through and first we need to get all the inputs. So there's various inputs from devices. So we have the seat input. We'll have the switches inputs if we use those for something, and we have the speed sensor input. We also will grab the friction setting off of each wheel, and we'll use that to determine if we're on doing a wheelie, if we have wheels off the ground or not. And as I type this in, you probably notice at some points that I have typos or mistakes and whatnot, and then when I compile this, I'll see the errors and correct them, or I will correct them as I test the code out. So now I'm doing this from memory. I have done this before with the previous episode, so I kind of know what I'm doing, well, more or less. Also working on a general pattern. So I like the pattern of the computer ports, define pound CP or dollar $CP for the various ports on the computer that are direct accessible. I don't create constants for names, like I don't create a constant for the left wheel and right wheels and that, like that. I just use the actual string. You don't find a value adding that extra indirection. And there, of course, is an error when I attempt to run it. So I'll go through and see if we got the gets when I created the channels there, so I have to fix that. So as the old saying with programming goes, is that it doesn't matter which convention you use as long as you're consistent with whatever convention you prefer to use. And that's the key thing. So I'm trying to, as I write more code, try to develop that convention. So for example, I always call the computer port CP with a number. For the channels, I'll use a 2-letter code representing what the component is with a get or a set. And then typically if I pull that information out, I will just use the prefix and the name without the get or set, as you see like in line 27. Some devices like the speed sensor only have a default channel of 0. And even when you look at the wiki, they won't specify any channels at all. They're just an assumed channel there. in this case. So I don't bother creating a constant for it. If it only has one channel, then we'll just put a 0 there. That's perfectly fine. Okay, so now I'm looking at the wheels on the ground. And as I said before, that the value when you first build a vehicle and in certain locations, I'll get 0. So I believe when I start this up, it will claim that there's 0 wheels on the ground. Of all 4 wheels, none of them are touching the ground, but obviously they are. This is I think I submitted this as a bug, and it's a minor issue. I compensate by factoring in speed. So what I did before, I had anti-wheelie logic that would kill acceleration, and so I had this coded before I factor in speed. Then I try to go forward, but I could not go forward because when I hit W to accelerate forward, the wheelie logic would kick in. Oh, you got more than 2 off the ground, will zero out acceleration. So basically, the vehicle wouldn't move anywhere, and thus I had to start factoring speed. And once it moves a little bit, it seems okay for the most part. It only happens sometimes. And what I'm doing here, I'm just counting them up. And the if used in this mode is, so if is like a function or a statement. I'm using it as a function now. And basically the first argument is true or false. And then base if it's true or false. If it's true, it picks the next argument. If it's false, it takes the last argument. And what I do is I grab one wheel, 1 or 0, and then I just add the other ones up. So now wheel on the ground will now indicate the number of wheels are on the ground. Okay, we'll update our display so we can see what's going on here. And this is sort of the pattern I use. I just start at 4-4, so the lettering is not crammed into the corner of the screen there. I'll put a text. Text is basically a formatting type mechanism where you can. So we'll display speed. Now, in the last series, I displayed speed in miles per hour, and which tells you what country I'm from. Well, one of 2 countries I'm from. And so I decided to go ahead and display it in both kilometers per hour and miles per hour. And so there's a magic factor. The raw speed is in meters per second, and we do a quick search on meters per second to kilometers per hour, or meters per second to miles per hour. We get these magic numbers, and that's where those magic numbers come from. So basically we'll default the kilometers, and then we'll also display miles per hour. So we'll have both numbers, making this a more internationally friendly vehicle. Now I have a lot of screen space, so I'm going to display other values like number of wheels on the ground. It's inherently not that useful because I kind of understand what's going on here, but just in case I displayed it. Also, this is very useful that if you have values or internals or how things are working, you're not really sure what's going on inside. A computer is nice because typically you have plenty of room in there to display various information, internals. For example, I could display for each wheel what the value is. And then, okay, so, and it should be if not in seat, not if no in seat. If I can spell. My touch typing skills have gotten rusty. So if using is 0, and that's fine, and then we'll put the brake on. Now brake can be turned on, the two-way brake on. One, if I hit 4, in my case, I'm using default binding, I'll get the brakes. Or if I'm not in the seat, the brake will automatically kick on. The other thing I also do is I go back in here and I'll set acceleration. I should set acceleration and steering too. And the reason for that, I typically use the I forget what I call it, the more variable setting on the seat, which means it's not 0 and 1 when you hit W. It builds up to 1 and then it slowly reduces down to 0 again when you take your finger off. So and that means if you're out of the seat, you're no longer you're not taking key input anymore, but you still have that factor of degrading. I'm pretty sure it still degrades, and so I don't want the brakes fighting the acceleration, so we'll just kill that. I haven't typed that in yet, but I believe I'll go back and fix that. Regen is interesting. Let's talk about regen for a moment. So in my playing around with regen, one, it does put power back into the battery. It's not a lot, and it doesn't have a lot of braking power. So let's say you're cruising along, and instead of using brakes, you just turn on regen. It acts like, there's still no brakes. It barely puts any force against it. Unlike in a real EV, when you try to do that, you'll definitely get some braking power out of it. So, and you can do some complex logic related to regenning this and that. So what I do, I keep it pretty simple. If the forward acceleration is over 0.8 or under 0.8, then we turn regen on. In other words, we turn it off. So basically, almost all the time, regen is turned on. And honestly, you could probably turn it on all the time and not affect your top acceleration. But just in case, I put that code in there. Also, if you go backwards at any speed, regen's always on. So I purposely wanted to go backwards, and if you're going backwards, you're not going to go that fast anyway. So turn regen on. Which means if I take my hand off of W, we'll have regen, and we're not, at least we get something out of it. And do that. So that's why I put that in there. It's a little bit of something. Why not? And above there, you saw I went back and added the lines to, if you're not sit down, then zero out the forward and the steering. And so we make sure that they're all appropriate. Okay, now I'm thinking what to do next. And as I develop this, I go ahead and hit save and set everything up and check for any current errors. And getting a little verbose, mostly, well, it's good to break it out. Also, hopefully it makes it a little more easier to understand for those watching the video. Now, one thing you notice, I'm doing all this through the source code method. I'm not using the nodes. I'm not a node person. This is how I started coding. Well, not with this game, but line by line coding. That's the way I learned to code a while ago. And I did a little node stuff. I did, like, when I first started, I used nodes and created a few things because they didn't really understand the language yet. But yeah, I prefer this. Now I'm more used to the language. And here I am. Okay, now wheel of the ground. So we count the number of wheels we have, and if we have, basic, plus, and 3. So we got, only 2 wheels on the ground, or only 1 wheel, or 0 wheels on the ground. Okay, so we're floating. So what we do, we just kill the acceleration. So what wheels we do have on the ground, we just kill that. Because sometimes what happens is, like, for example, you're moving along, and the front wheels come off the ground, but the rear is still going full bore. And then now you have this lifting action because you're tilted and the bottom of this is kind of flat. So we sort of have a little small wing on here, and now we roll over and flip over. So what this does here is, okay, we'll just kill the acceleration, so hopefully we'll pop back down again. And at least we don't try to make it worse. Now if we don't catch it soon enough, we're still gonna flip. And here I'm going to dampen the steering, so if I hit steering, we don't go too hard. I think I overdid the dampening, but you can always adjust this. I could have just made this 1 initially, and then that way it has no damping effect, and then I can just change it afterwards. But in other vehicles, I found this is useful. I think it was very useful for building a ship. It was quite useful. And I think I boost that up later on because I think it's a little too not enough. The other reason damping steering is I had a lot of problem with rollovers, so I would like try to turn, and I turn too quickly, and the vehicles roll over. That happens in the previous series. Now that vehicle was narrower. This is a little bit wider, so this should have a little more resistance to roll over. All right, so this is where naming comes useful for the wheels, and why you pretty much don't want to use ports. So I can use the star value. So now we're going to apply setting to the wheels. So we're going to set the acceleration. So we accelerate all the wheels. And there's some fancy things I can do related to acceleration on the wheels. So for example, let's say the front 2 wheels came off. Instead of just killing acceleration, I can actually reverse the rear wheels to help bring that front down faster. And in the same way, if the back comes up, you could accelerate the front wheels to try to bring the back down. So I don't do any of that stuff, but there's a lot of interesting scenarios you can handle this code. And I'm trying to keep it reasonably simple, but you could probably spend probably a whole day just tweaking and customizing and testing and all kinds like that. And looking for the bug I have. Okay, so I saved down there. All right, so now we're not setting the brake yet. So right now I think the brakes, as I recall, the brakes are retained. So we turn the brakes on; they stay set until you unset them. So we should be fine of rolling around. We'll set the brakes here. Since we're not seated, now we'll make sure we engage the brakes. And when we sit down, it'll unengage the brakes, which is also important. Okay, so we got the acceleration, regen, brakes. So now we need to worry about steering. So now the steering, we will have 4-wheel steering. So and for the basically for F, so basically the front wheels, front left and front right. This will cover the front 2 wheels, and we'll set that, which is wrong. The typo there. I'll fix it. Don't worry. And we'll set the rear wheel. So basically, we'll invert the 2. And so we'll move the front wheels one direction, the rear wheels in the other direction. Now I believe I'll dampen the rear wheels a little bit more. Not for any particular reason, because I think in real life cars, vehicles with 4-wheel steering, they dampen the rear wheel a bit compared to the front wheels. Although I think they do that more for there's not as much room in the back for moving those wheels, so they have to restrict them more than for anything else. Okay, so here I am trying out the wheels, making sure they steer in the direction. Hold down the keys, make sure all the wheels moving. Well, that's what it's called, smooth control. So smooth control on the C will slowly ramp up to 1, slowly bring down from 1. So when you initially hit S or D, the wheels are not going to immediately go full 1. They'll ramp up slowly, so you can make more fine-tuned turns. So I'm going to loosen that up a little bit so it steers a little better. I could probably go even further on that. I think I got these wrong. Okay, so I'm checking. Oh, and I got the typos in the wheel stuff when I mess around here. This is why it's good to test this while it's sitting. See, the rear wheels are not moving at all. That one did a little bit. The other one, see, they're not moving. The rear wheels are not moving. And this is why it's kind of nice to test this while we're not moving. And so I'm going to stare at the code and go, what did I do wrong? Now, hopefully you all saw it. Yeah. I'm setting the front wheels twice. Okay. Okay, that's better. Yeah, I could probably undampen those a little bit more. The other thing to do is have the steering based on speed. And so the faster you're going, the more you dampen the steering. Sort of dynamic control on that. And that will help reduce the turning too quickly at high speeds and rolling over. And as I said, it's just a lot of adjusting the forward and backward. It's hard to see which way they're really going. I'm still anchored, so we can't really go anywhere. And you see on my display it says on ground 0, and it thinks all 4 wheels are off the ground. So, all right. And also something else I want to do also, which I didn't do last time. So I want to pull the information from the drill of what's under it. And I'm gonna do an overkill. And so basically in the wiki under Celestial, look at the actual link. You look at the wiki at the very top under gameplay mechanics, you'll have celestial bodies and resources. You expand that, look at Earth. It will give you all the elements in, are they everywhere, high mountains, low altitude, and the rarity of them. And so there's a number of elements that are available in the mountains. So I figured, well, let's just display all of them. Maybe we get lucky, and find something and drive over it. The mining drill has a number of interesting channels. I only map. You get how far, the efficiency, how deep it's going, things like that. But I care about the composition, which is a text field that is a key value, set of key value pairs, and the key is the actual element name, and the value is the fractional based on 1 of the value. Okay, so we're going to get the composition of the mining drill, and then I'm going to have a typo here. And because of this mistake, quiz for the people watching, what value will be set to in decomposition? And we're going to do a little debugging here, so we're just going to display the total value. I haven't really played a lot with key value pairs. There's a lot of little things you can do with them. You can break them apart and put them in arrays and put them back into a set, and use for each loops on them, and all kinds of other interesting things. And always forget that last parent on that. Okay, so you see I have a 1 there, test 1. And so I go, oh yeah, that's a text. It's a text field, not it. So if you have a text field and you get a number, it'll return 0 if the text is empty, and it'll return 1 if the text is non-empty. And in this case, it's not empty, so return 1. So, all right, so we have now a value. That's our key value pair. We're only getting this stuff underneath us, so all the other elements are not, not showing up as 0. They're just not in the list. So I started off going, well, we only care about aluminum. Aluminum is the only thing there. So let's just pull out aluminum and display it. And since there is no aluminum, it's a blank field. And I'm pretty sure I can put a colon number there and convert it into a number, or at least put it into a variable, and that variable cast it back to a number. So I'll at least have a 0 or something there. But then I said, well, let's just do all the rest of it. There's looking at that wiki of all the other elements. Let's just do all the rest of them. Let's break them all out, and we got room on the computer screen. Maybe, I don't know. I haven't played in the mountains that much. Maybe we go up there and we're looking for some aluminum, and we find a little bit of tin or silver or something else, and go, wow, that's interesting. And so I figured just kind of render all of them. The other thing I could have done, is that, let's say we're looking for aluminum, which we are, and I had a threshold that if I find 20% or higher aluminum, I want that. So what I could do is I could trigger, I don't do it in this code, but I could set it up that if I roll over 20% aluminum, to engage the anchor and basically just stop us. Now, if we're bouncing or flying a little bit and we're a little too high, anchor will not engage. If you're flat on the ground, anchor will engage. So it's not, but we're kind of assuming if we're kind of, if we're sitting on the ground, it'll engage. If it doesn't, it won't. And unfortunately, it's hard to know if you engage or not. I guess the only way to know if your speed went to 0, then you kind of know you engage the anchor, I guess. And if the speed keeps going, then you have to reset the anchor. It's kind of interesting coding to do all that stuff, but it is possible. And that way you sort of drive over. Aluminum's not that hard to find. You can find some aluminum without any real difficulty. Even in a flat area, you head to little hills, and even some spots in the flat areas, a little bit of aluminum in those areas. And in the next episode, I'll drive around and go hunting. And you'll see how well the anti-wheelie logic works. So right now I have like the wiki. Now I'm just trying iron just to see how it renders. So what I'm curious is how wide the output will be for actual values. I figure I'll use values I know I have. I really didn't need to change the text letters for this test. Okay, so now, all right, so we have that. So these are percentages. So obviously you got to multiply by 100. So it's 0.25 is 25%. So the other thing I thought of after this video is I could have created a function, and I could have taken the 0.25 multiplied by 100 and rounded and returned 25%. And that would have saved space and made it a little nicer type thing. But I don't do it here, and I don't do it in the next video, so I just have to do the math in my head. But I definitely would make it a little nicer. All right, so we tested everything, we unlocked it, and looks like we're going to do a little test spin. We haven't used our toggles button yet. We'll use one of those for the mining drill in the next video. Go forward. Now this thing moves. When you hit that W, this thing just leaps forward and really wants to go fast. which is almost a problem because it goes a little too quickly. Here I am just going to put some formatting for these values so I don't have too many numbers in there. Okay. I mean, it really just, it's dangerous because you just kind of tap that W and it's all of a sudden we're going. And it's hard to like precisely maneuver it. I think I should need to dampen it based on speed. I'll make it, geometric. In other words, if you're going slow, the acceleration has a high dampening, and as you go faster, the dampening is reduced. That way I can sort of, kind of move around in like a parking mode or low gear mode or whatever and move around a little bit. Now I do not mess with the gearing yet. There's a whole gearing aspect where you can kind of shift the gearing up and down on the wheels. And let me fill my backpack, which we don't get to yet. Okay, so I think this is about the end of this video. I'm just going to load up extra shelf just to make sure I have way too much junk on me. And then next video we'll take this baby out for a ride and do some mining. Until next time, see ya.